Hello and welcome back to Business Analytics. This is Hari Rajagopalan and I will be going over this lecture today. So today hopefully all of you have completed your one sample hypothesis testing and have a good idea of what hypothesis is. And in this lecture, we are going to cover the first part of two sample hypothesis testing. Now, what is the difference between one sample and two sample? Well, one sample uses one sample and two samples use two samples. Now, before we get into the details of how to do the test, it's very important for us to look at Excel and make sure that you have installed the data analysis tool pack in Excel for you to access some of the functions in Excel. So Excel comes with its own default statistical analysis toolkit, and it should be present in data analysis. If it is not, you click on it, go to File, Options, Add-ins, Manage Excel Add-ins, click Go, select Analysis Toolpack. And so here is Options right here at the bottom. You can see that under File. Then you go and click on Add-ins. Then click Go. And then make sure this is checked. So let's do this one more time in Excel. Here we are in Excel. If you click Data, you should see Data Analysis right here. If you don't see Data Analysis here, go to File, go to Options, go to Add-ins, click Go, and make sure this Analysis tool pack is checked. Okay, and if it's unchecked, this data analysis will disappear. Click it on and click OK, and you should see data analysis appearing here. Going back to our slides. So once you have that, you have the access to the statistical tool pack. Now let's talk about two sample hypothesis testing. As I mentioned before, one sample hypothesis testing, you take a sample and you compare it to the null hypothesis value. In a two sample hypothesis test, you take two samples and you're comparing them to each other to see if they come from the same population or from different populations. Now, how many different tests are there in Excel for two sample hypothesis testing, and what are they? Well, we have the z-tests, two sample for means, and remember z-test is when you have the population standard deviation is given to you. We have the t-test, two sample assuming unequal variances. Remember that variance is the square of standard deviation. So if you get standard deviation, if you square it, you get your variance. You have t-tests, two sample assuming equal variance, and we'll go over why these two need to be done. And then finally, you have t-test paired two sample for means, and we'll talk about that, which is a special case of a t-test. So as you can see, once you click data analysis, you will get this window, and you have 1, 2, 3, 4 different kinds of tests here. So let's start with the first one, and this lecture is all about z-tests, two sample for means. We're going to compare two groups. So let's look at two groups. We have students who are online, learn online, and then you have students who learn traditionally, which is in the class, face-to-face. And the question is, do they perform differently? Is the performance different, right? So we are here, what we are doing is we are taking independent samples. And until we come to paired t-test or matched samples, we are going to always take independent samples. And what does this mean? It means that each group contains a unique set of people or items. Students in face-to-face group are not present in online group. So if we select 30 students online and we select 25 students face-to-face, they are very different students, and there are totally 55 students in the study. Does that make sense? So you have two groups and two complete sets of people or items that you're randomly selecting. So the null hypothesis, of course, here is there is no difference between student performance in online and traditional face-to-face. The hypothesis, and the reason we're doing this, is that there is a difference between the two. And since we're talking about a difference, this is obviously a two-tailed test, right? This is not a one-tailed test. This is a two-tailed test. So the next slide, we're going to state the entire problem. So it's to see if there is a difference between online and face-to-face students. We are randomly taking 30 students who have taken statistics, a class in statistics online, and another 25 who have taken statistics face-to-face traditionally. So we have two groups here, 30 who are doing it online and 25 who have taken it face-to-face. We also know, and this is basically from past data. You're going to use your past data, and online students, the population standard deviation is about 2, and traditional face-to-face students is about 3. So remember here standard deviation, and this is important, the population standard deviation is given to you for online students and face-to-face. And normally, in a practical terms, you have these population standard deviations, especially if you have been doing this for a long time. If this is the first time you're teaching online, you probably don't have data for population standard deviation. But if, let's say, you've been doing it for 15 years, you have data on both sides. And it says perform a hypothesis test. So the first thing, whenever you see this hypothesis test, is for you to identify what kind of hypothesis test you should do. Well, in this particular case, this is a 2-sample hypothesis test, and you have a z-score. So, I mean, because you have population standard deviation, you are going to use your z-score, not your t-score, right? So it's a 2-sample hypothesis test. And also, finally, when you say there is a difference in performance, it's going to be a 2-tailed test. So there are multiple things here involved. First is this a 1-sample or a 2-sample hypothesis test? You've got 2 samples, so it's a 2-sample hypothesis test. Second, it's a 2-tailed test because the hypothesis is about a difference, right? And finally, it is also a z-test, not a t-test, because you have population standard deviation. So make sure that you always have your hypothesis and null hypothesis stated for any test. It needs to be stated right there. Then you should state your type 1 and type 2 error. So type 1 is we conclude there is a difference in performance between online and face-to-face students when there is actually no difference. Type 2 error is we conclude there is no difference in performance between online and face-to-face students when there actually is a difference. So it's very important that you write out your type 1 and type 2 error in English, in language that you can understand. Then you decide on the test. In this case, we have decided it's going to be a z-test, right? Why are we doing the z-test? Because we have population standard deviation for both groups. So let's go back here and take a look at this z-test here. So you can see here, this is the window in Excel that you have the z-test. You're going to select all the data for online performance here. You're going to select all face-to-face performance data here. The hypothesized mean difference is always going to be 0. There are cases when it need not be 0, but for this introductory to business analytics, you can assume that the null hypothesis is essentially saying there is no difference between the two, and therefore it is 0. And here we are going to get our variances. Remember, we had variance standard deviations of 2 and 3. So variances is the square, so that'll be 4 and 9. If your data has headings, you're going to select labels. Here is alpha. I think we used alpha of 1%. And here is where you want the output. Now let's recreate this whole thing in Excel. So here we have Excel. This is already, the problem is already solved. And like I said, any problem you do you should state your null hypothesis, your hypothesis, your type 1 and type 2 error. And now we're going to go to data analysis. So essentially, if you look at this, this tells you where to go. Data right here, data analysis. You're going to scroll down to z-test, which gets you this interface. Variable range 1 is your first column. Variable range 2 is your second column. Hypothesized mean difference is 0. And then you're going to look at standard deviation of 2. So variance will be 2 squared, which is 4. Here it is 3, and that's 3 squared is 9. And since we selected the headings, we're going to select labels. Alpha is going to be 1. And here our output range. I'm going to not put this here and spoil, but I'm going to, basically it'll take away what we've already done. So I'm going to go ahead and place this here. Now some suggestions for a lot of you, because a lot of you struggle with the formatting here. First thing to do is to select these z values and the mean and turn them into 2 decimal or worst case 4 decimal numbers. Also these p values here, go ahead and make them percentages with 4 decimal places. And it's easier to compare percentages. It's easier to compare a 3% to a 5% or a 0.5% to 1% rather than comparing 0.05. A lot of you make mistakes when comparing 0.05 or 0.005. So go ahead and format it to percentage values. So now I've showed you how to get this, and we can go back here. In a two-tailed test, you can either choose, you get 2 p-values here. And the 2 p-values are going to be, in this particular case, they are the same, but they can be different depending upon how far the 2 means are away from each other. So here we have p of whether it's one-tailed, and here it's two-tailed. Now you can use either one of these p-values, but if you choose to use this one-tailed p-value and ignore the two-tailed p-value, you would have to compare it to alpha by 2 because this is a two-tailed test. And alpha by 2, which is alpha is 1%, alpha by 2 is 0.5%, and 0 is less than 0.5%, and you can reject the null hypothesis. If you choose to use the two-tailed p-value, you do not have to divide your alpha by 2 because this value is 2 times this value, and so you can just compare it directly to alpha, and in this case it does not change the answer, and you can reject the null hypothesis. So it doesn't matter which one you use, just pick one and stick to the method, right? Either use alpha by 2 here or use alpha, pick the method, and you can conclude there is a difference in the average performance between students who learn online and those who learn face-to-face. And you can see that here. The average is 70 for online, 78 for face-to-face. Going back to PowerPoint. And therefore, here we have our answer. This is just copied from Excel. And again, I'm reiterating, and this is really important, you can either use this p-value or this p-value, but pick one and stick with it. If you use one-tailed, you have to compare it with alpha by 2. If you use the two-tailed, you can compare it directly with alpha. And it's important, if you mess this up, you can end up with wrong results. In this situation, because of the way the answer is, you end up with the same results, but it's very important for you to pick one method and stick with it. So personally, I prefer to ignore this two-tailed and just stick with the one-tailed, because when we do one-tailed test, we'll be using this p-value, and I will manipulate alpha or alpha by 2 depending on whether it's two-tailed. I use alpha by 2. One-tailed, I use alpha. So p-value less than alpha by 2, and you can conclude there is a difference in performance. So I'm going to go over pretty quickly the next few questions, which are going to be very similar. The steps are going to be similar, except now one is a lower tail test, another one is an upper tail test. So we expect online students to perform worse than face-to-face students. And now again, we are taking data. 30 students online, 25 face-to-face. Population standard deviation is given. And you are asked to perform a hypothesis test and assume alpha is 5%. So remember here, instead of difference, we expecting online students to perform worse. And so always you start off with doing the null hypothesis and face-to-face. Null was they do not perform worse. Your hypothesis is students who learn online do perform worse. You also write down your type 1 and type 2 error. We conclude students who learn online perform worse than students when they actually don't. And type 2 errors, we conclude they do not perform worse than they actually do. So you're going to go do the data analysis, z-test, 2 sample for means, the same steps as you did in a 2-tail test. There's no difference here. But it's a 1-tail, lower tail test. You can look at the data. And now for a 1-tail test, you are not going to use this. You're just going to use 3.4986 p-value here. So here are the means. You can see online, they scored on average about 71, close to 72. On face-to-face is close to 73. Here is the known variance because you have population standard deviation. Here are the number of observations. Hypothesized mean difference is 0. The z-score for the difference between these two is given here. This is the critical value. So obviously here, this is your p-value. And so you're going to reject the null hypothesis and you conclude that online students perform worse than face-to-face students. And here you have a confidence of more than 95%. And where did I get this 95%? It's 1 minus alpha. So it's a confidence you have when you reject your null hypothesis. The confidence with which you reject your null hypothesis is greater than your 1 minus alpha. The next problem is an upper tail test. In this case, we have students in hybrid classes, and we expect them to perform better than students in online classes. So you take 30 students in a hybrid class, 25 in an online class. You have some data, and you're going to run the numbers, right? And here's the population standard deviation for students in hybrid class is 1.5. For online classes is 2. We're going to assume alpha is 5%. Again, go through the null hypothesis. Students who learn in a hybrid mode do not perform better than students who learn face-to-face. And your hypothesis is they do perform better. Your type 1 and type 2 error are given here. You can read through them. They're pretty much the same. The pattern is the same. You conclude that your hypothesis is true when it's not. Your type 2 error, you conclude that your null hypothesis is true when actually it's not, right? So go through these two. And so you're going to do a z-test for 2 sample for means. And it's a 1-tailed upper tail test because we assume that the first group is better than the second group. And you end up with this data. You are not going to use this 2-tailed. You're just going to focus on 1-tailed. The p-value is 5.53%, right, which is greater than alpha. So you fail to reject the null hypothesis. You cannot conclude that students in hybrid classes perform better than online students, even though the average is 71.73 and hits 70.95 here. You cannot conclude that. We don't have the power analysis for us to tell the confidence. The confidence here is 1 minus beta, and we haven't gone over the power analysis for a 2-sample test. Now, a lot of other softwares actually generate the power analysis, and that could be very, very useful. So with this, we finish this. I'll quickly show you the Excel file for you to look at, but it'll be a very quick look, and you can go over it in detail. Here is the Excel file, and here is the data for the lower tail test. Again, you will go to data analysis, same Z2 sample for mean. you will select your ranges. You'll put your hypothesized mean difference. Your alpha is 0.05 here, and you will generate your data, right? Similarly, for your upper tail test, here's the data for hybrid and online. Make note that the standard deviation has changed. So when you do this, your variance for group 1, right? This is where range 1, range 2, your hypothesized mean difference is 0. 1.5 squared is 2.25, and 2 squared is 4. You must change that, and then you can run your data sets. And here are the results here. Okay. And with this, we finish 2 sample hypothesis testing with z-scores.